So today I want to talk about how Kepler's laws actually resemble Newton's laws of motion, or specifically the conservation of momentum. So I'll turn this around. Let's see. You probably want to see it like this. So mass times acceleration equals mass times acceleration. That's for like the left side of a collision and the right side of a collision. You can tell that if a bigger person runs into a smaller person, right, the smaller person is going to go flying backward more. That's what that kind of shows. And then the m times v equals m times v before and after. That's the other component for each direction. So you could see that v has to change because m is changing. So that's like Newton. And then come over here, and you could see it has the same kind of format, even though it's talking about different things. So m times d equals m times d. That's like the mass of the Earth and the mass of the moon. Imagine it as one thing rotating, not two orbits. I'll get to that in a second. You could see there's an oscillation, and so the distance on both sides of the equation is going to have to change right here. And then there's also the distance from the center of mass of the system times the velocity is going to stay the same. So if the distance decreases, the velocity of the moon or planet is going to increase. So you can see how these kind of look the same in form. And the reason why they do is because they have the same conceptual composition, like asymmetry in quality without asymmetry in quantity for left and right, and then you have symmetry in quantity with an asymmetry in quality for before and after. And like I was saying before, you could re-describe physical laws and physical phenomena and all phenomena in terms of combinations of opposing concepts, and they come in sets of four. These are like two out of a set of four, and I'm just comparing them. Look at those equations. Now, think of it as one thing rotating, not two distinct orbits. Masses aren't separable from a coordinate system, a separated coordinate system. It's not as if planets are moving through a hidden fluid, are moving in relation to a hidden fluid in addition to moving in relation to each other. It's like this extra frame that they're adding to it, like, an ether. So we want to get rid of that, just like the space-time medium itself. Sometimes they think of it as a solid, sometimes a fluid, sometimes a gas, like the expanding Big Bang, right? So they're just taking an abstract geometrical version of ordinary phenomena. This is their left hemisphere that's doing this. And then they're confusing it for the phenomena itself. And here's another thing. They're taking like the picture of a bowling ball denting a mattress, except it's a planet denting a hidden space-time medium. So this picture of a bowling ball denting a mattress is meant to explain a bowling ball denting a mattress. Do you see what I mean? So they're taking a hidden picture of an ordinary phenomena, and then they're trying to make it the explanation, an abstract explanation for the phenomena itself. And that's what use is a hidden cause if we don't understand what a transparent cause is. Wittgenstein used to talk about that. What else? No, I think that's it.